In this problem, we have a 7.3 times 10 to the power 3 kilogram space vehicle, and it also has an empty 6.8 times 10 to the power 2 kilogram booster unit, which are moving together at a speed of 370 meters per second. Then there's an explosion which lasts 2.2 seconds to separate the two parts. And then the speed of the space vehicle after the separation is increased to 430 meters per second, and we want to figure out what the impulse is on the booster unit. Okay, so just before we kind of organize this problem, what we're saying here is that the space vehicle is 7,300 kilograms, and it's attached to a booster unit which is 680 kilograms, and they're moving together at a speed of 370 meters per second. Okay, so if I go to this diagram right here, let's go ahead and label this object here. So we have 7,300 kilograms for the space vehicle, and then we have a booster unit which is attached to it at 680 kilograms, and this is moving together at a speed of 370 meters per second. Okay, and then there's an explosion that happens. So now the space vehicle and the booster unit have been separated. All right, and I think the question stated that the explosion lasted 2.2 seconds, and then the speed of the space vehicle has increased to 430 meters per second, and we want to figure out what the impulse is on the booster unit. Well, it turns out that the impulse is pretty much going to be very similar to the space vehicle and the booster unit. So we just got to figure out the impulse for this particular problem here. Okay, so if I want to figure out what impulse is, let's go ahead and write out the formula for impulse. So an impulse is really a change in momentum. And the change in momentum is really your mass times your final speed minus your mass times your initial speed. Okay. So we know that the initial mass of the space vehicle is 7,300, and it's moving at a speed of 370 initially. And then after the explosion, the space vehicle, which maintains its same weight, is now moving at a speed of 430 meters per second. Okay, so let's go ahead and plug those numbers in. So the mass of the space vehicle is 7,300. And the final speed was 430 meters per second. And then we subtract the initial momentum, which is 7,300. And we times by the original speed, which is 370. Okay. And once we calculate that, we get 438,000. And the units for impulse is basically momentum, which is kilograms times meters per second. But we can also use units of newtons times seconds here. So when we're calculating impulse, the impulse that acts on the space vehicle is actually the same impulse that acts on the booster unit. So this right here is your correct answer for the impulse for both the space vehicle and the booster unit. Okay, so if I go back to the multiple choice options here, the best option here would be option D. All right, so 4.4 times 10 to the power 5 newtons times seconds, and that's the impulse there. Let's take a look at another impulse question. And for this next problem, we have a 5 kilogram ice block, which is sliding along a smooth floor at 1 meters per second west. And then we have a 0.20 Newton force, which is directed east, acting on it for 4 seconds. And we want to find the magnitude of the block's final momentum here. Okay, so let's go ahead and collect some information for this particular problem here. So we know that the given mass for this particular problem is 5 kilograms. And we're actually given its velocity in this particular case because it states that we're going 1 meters per second west. So if we're going the west direction, let's just put a minus sign there, and we'll write down 1 for the magnitude there. So the velocity is -1 meters per second. And then we also have a force acting on this object, which is 0.20 newtons. And the time that we have for this particular problem is 4 seconds. And we want to find what the final momentum is. So we want to find PF, which is the final momentum. Okay. Given that information, now let's go ahead and write out the equation for impulse here, which is really a change in momentum. All right, and a change in momentum is really your it's your final momentum minus your initial momentum. And impulse is the same thing as force times a change in time. Okay, so now we have a force times a change in time for our impulse on the left-hand side. Final momentum we can leave as PF minus, now our initial momentum, well, the formula for initial momentum or momentum in general is mass times your initial velocity. Okay, so now we have all the information that we need, and now we can just plug in the information here. So we know the force for this particular problem was 0.20. The time acting on this particular problem was 4 seconds. And then we got to find what our final momentum is, which is PF, minus the mass for this problem was 5 kilograms. And the initial velocity here was 1 meters per second in the west direction. So we'll write in -1 like that. Okay, and now we have enough information to find what we're looking for here, which is the magnitude of the final momentum, which is PF right here. If I multiply 0.2 times 4, we get 0.8 equals to your final momentum. And then if I multiply -5 times -1, I get +5. Okay, so if we figure out the magnitude here, I have 0.8, the magnitude of the final momentum, and then I can subtract the 5. And then we get an answer of -4.2 for our final momentum here. Okay, so this negative sign means it's acting in the west direction, but the magnitude here is going to be 4.2, and the units are kilograms times meters per second. Okay, so if I go back to my options here, the best option here would be option B. The magnitude is 4.2 kilograms times meters per second. Here is another similar impulse question here. And for this problem, we have a 0.26 kilogram ball traveling due west at 22 meters per second. And then it's hit by a bat, and as a result, the ball travels due east at 18 meters per second. If the bat remained in contact with the ball for 0.13 seconds, what is the average force that the ball exerted on the ball? Okay, so let's take a look at this problem now, and let's start off by collecting some information here. So we know the mass in this particular problem is going to be 0.26 kilograms. We know that the initial velocity for this problem is going to be, well, it says 22 meters per second west, so let's put a minus sign there for the west direction, and the initial velocity would be 22 meters per second. And we know that the final velocity, since it's going in the east direction at 18 meters per second, we can say the final velocity is just 18 meters per second. And the time that's acting on in this particular problem is going to be 0.13 seconds. And we want to find the force that's acting on in this particular problem here. Okay, so just like the previous problem, let's start off by writing impulse. So impulse is equal to a change in momentum. Okay, it's a change in momentum there. And another formula for impulse is really force times the change in time. And when we have a change in momentum, what we're really saying here is your mass times your final velocity minus your mass times your initial velocity. Okay, and our goal here is to find the force that's acting on in this particular problem. Okay, so we have a force. Let's just leave that as just F. The time that we have for this problem is 0.13. The mass that we have is 0.26. Now we have the final velocity, and the final velocity here is going to be 18. So let's just times this by 18. And then we're going to minus the mass again, which is 0.26. And then what is the initial velocity? Well, the initial velocity was -22 because it's going in the west direction. So we can times this by -22. Okay, and then with that, we should have enough information to find the force that's acting on this problem here. On the left-hand side, we can write down force times 0.13. And then if I multiply 0.26 by 18, I believe that's going to be 4.68. All right, and then we have two negative signs here, so basically we can change that to a positive, and we get positive 5.72. Okay, all All right, if we go ahead and just keep on simplifying this problem here, just little calculations here to kind of work out, we get 10.4 on the right-hand side, and finally force is really going to be 10.4 divided by 0.13, and this works out to be roughly 80 newtons. Okay, so if I go back to the multiple choice options that are given to me, option B would be the correct answer here. Let's keep on continuing on with these impulse related questions. And for this next question, we now have a 0.080 kilogram tennis ball and is traveling east at 15 meters per second. And then it's struck by a tennis racket, giving it a velocity of 25 meters per second west. And we want to find the magnitude and the direction of the impulse given to the ball. Okay, let's go ahead and collect some information again. So the mass of the tennis ball in this problem is 0.080 kilograms. We know that the initial velocity is going to be 15 meters per second in the east direction, so that's simply going to be 15. And then we know that the final velocity in this problem is going to be 25 meters per second in the west direction. So since it's going the west direction, let's put a negative sign there, and then we'll write 25. And we want to find the magnitude and the direction of the impulse. So we want to find out what impulse is equal to. All right, so let's go ahead and write out the formula for impulse here. Impulse is a change in momentum. All right, so a change in momentum is really your mass times your final velocity minus your mass times your initial velocity. Okay, so the mass that you have in this problem is going to be 0.080. Your final velocity was negative 25. And then you're going to subtract the mass again, which is going to be 0.080, and the final velocity, the initial velocity for this particular problem was going to be 15. Okay, so let's go ahead and calculate this. So if I calculate 0.08 by negative 25, we get an answer of negative 2, and then minus, and then if I times 0.08 by 15, I get 1.2. Okay, so this will be negative 3.2, and since we're talking about impulse here, let's just use the simple units newtons times seconds. All right, so the magnitude is 3.2, and this means that we are going in the west direction because of that minus sign. Okay, so if I go back to my options here, I guess we have 3.2, and we're going in the westward direction here, so the best option here is option letter D. Let's take a look at another impulse question that involves a collision. And for this problem, we now have a 2 kilogram cart, which is traveling east at 4 meters per second. And then it hits a stationary 8 kilogram cart. Now, after the collision, the 2 kilogram cart bounces back towards the west at 2 meters per second, while the 8 kilogram cart travels east at 1.5 meters per second. And we want to find the change in momentum for each of the carts. Okay, so let's take a look at a before and after situation here. So in the before case, we did have a cart that was 2 kilograms. So let's just say this is 2 kilograms. So the mass here is going to be 2 kilograms. And the velocity, the initial velocity for this particular problem was 4 meters per second and was going in the east direction like that. Okay, and then we had a stationary 8 kilogram cart. All right, so this mass over here is going to be 8 kilograms, but its velocity is going to be 0 because it's not moving. Okay, in the after situation, after the two objects collide, the 2 kilogram cart now is now moving in the west direction, so it's going to the left direction. The mass is still going to be 2 kilograms, but now its final velocity is going to be roughly, I believe it was going in the west direction at 2 meters per second. So since we're going the west direction, there's a minus sign, and we'll write down 2 meters per second for the velocity there. And for the 8 kilogram object now, well, its mass is still going to be 8 kilograms, but it's actually going in the east direction now, right? So this mass is still 8, but now it's going in the east direction, and its final velocity was going to be 1.5 meters per second in the east direction. So we'll keep that as a positive. And we want to find the change in momentum for each cart. Okay, So let's take a look at the change in momentum for the 2 kilogram cart. So change in momentum, I'll write down a change in momentum for the 2 kilogram cart is really your mass times your final velocity minus your mass times your initial velocity. Okay, so we're dealing with the change in momentum for the 2 kilogram cart. So we're looking at this information here, which I'm highlighting in yellow. Okay, so if we go ahead and plug those numbers in, the mass is going to be 2 kilograms. The final velocity here was -2 meters per second because it's going the west direction. All right, and then we minus the initial mass, which is 2, and the initial velocity is going to be 4. Okay, so if we go ahead and compute this, we get -4, and then we minus 8. So -4 minus 8 is going to be -12 kilograms times meters per second. And basically this minus sign just means that we're going in the west direction. Okay, so west, and then if you want to write 12 kilograms times meters per second, that is the change in momentum for the 2 kilogram cart. Okay, so we're going 12 kilograms times meters per second in the west direction. Okay, so if I go back to my multiple choice options, I guess option D is the only one that actually works. I get the 12 for the magnitude and the direction is west. Okay, let's just go ahead and find the change in momentum for the 8 kilogram cart for the practice now. Okay, so if I want to find the change in momentum for the 8 kilogram cart, so change in momentum is the mass times the final velocity minus the mass times the initial velocity. Okay, so now we're dealing with the 8 kilogram cart, so I'm looking at the information that I'm highlighting in green here. So if I want to find the change in momentum for the 8 kilogram cart, well, the mass is going to be 8, and the final velocity here is going to be 1.5, and it's going in the east direction, so it's going to be positive, minus the original mass was 8 again, and since it's stationary at the beginning, its velocity is going to be 0 there. Okay, so the change in momentum here is simply going to be 8 times 1.5, which is 12 kilograms dot meters per second, and since it's positive, we have a positive sign here, it's going in the east direction. Okay, so if we go back to the multiple choice answers here, I guess these are our best answers here, 12 east, so the best answer here is going to be option D. So that is the change in momentum for each cart.